In this video, I want to introduce best subsets regression. Best subset regression is similar to stepwise regression in that it is a method by which we can identify the set of variables we want to include in our regression model. It is also a little bit different. Stepwise regression goes through an iterative process of trying to add a variable and then remove a variable and then add another variable and then remove a variable. Best subset regression, on the contrary, is just going to try to run all k factorial possible permutation of our explanatory variables, where k is the number of explanatory variables. So it's going to try to run all the regressions and compare their performance. Here is a process map for best subset regression. First, you start by defining all the variables that could enter your model. Then you're simply going to tell what is your model selection criterion. This is either going to be the adjusted R-square or the CP statistic or both. We are going to see later that in general we might use both and then simply validate the models out of sample. You're going then to run all the k factorial possible combination of your explanatory variables. So that's a very large number of linear regression. And then you identify the best model based on the in-sample fit statistics that you selected, so either R-squared or the CP statistic. There is a far greater computational cost in running this than for stepwise regression, and that's why best subsets came into popularity when we had better computers. Here is how you might use a best subset in R. So I'm going to load the data, which is the same data as for stepwise regression, and we are going to use the same set of potential explanatory variables. So year of release of the video game, critic score, critic count, user score, user count, and if the game was released on a PlayStation platform or not. Instead of running best subset manually with all the possible combination, we are going to use a package called leaps. So we are going to load leaps by writing library leaps. If you get an error, you might try to run install.packages leaps. You have to do that only once, but if you haven't installed leaps in the past, it might be necessary to run this. And then leaps is going to run best subset for us. So here it's going to call the function regsubsets. And we write the model with all the possible variables. So here global sales is regressed on year of release, critic score, critic count, user score, user count, and PlayStation. In the data frame my data, and I can select the maximum number of variables I want to include in the model. Let's say I want to include at most 5 variables. So I'm going to run this and save the result into the variable models. So I run this, and let's check the summary of models. Here it tells you basically what model might be the best performer. So first model might be not including year of release, critic score, critic count, it does include user count, and not PlayStation. For the model 2, it didn't include the 2 first variables, but it did include critic count and user count. And you can see it has 3, 4, 5. So these 6 variables could enter various models or not enter them at all, like year of release didn't enter any of the 5 selected models. Now, which one should you pick? Well, we're going to look at the summary statistics for some of these models. So first I'm going to save the result of the summary in ResSum for summary statistic. And I'm going to look at, in ResSum, the adjusted R-square. So adjusted R-square, higher is better. I'm going to look also at the CP statistic. In that case, lower is better. And I'm also adding the BIC, Bayesian Information Criterion. We are not covering it in this course, but it's good to know where to find it. And so also lower is better. Here is a data frame, and it's telling us that for model 1, the adjusted R-square is 12.4%. So model 1, just add user count and that's all. For model 2, it was 15%, 21%, 22.8, 22.8. So we see that the highest adjusted R-square seems to be model 4, 22.87%, 88 if we round up actually. For the CP statistic, the best model is also model 4. It has the lowest CP statistic. And for the BIC, it's also model 4. So here all the statistics seem to agree that the best model is model 4, which was critic score, critic count, user score, and user count. We see that it seems to match what we found with stepwise regression. If I want the coefficient for the model, I can just write coef and then where my models are, so in the variable models. And I want the model number 4. And here we have the intercept and the slope for critic score, critic count, user count. Of course, I can also run the regression manually. So summary linear model, and then I'm going to copy the variables. So year of release didn't make it in model 4. We have critic score, critic count, user score, and user count. So PlayStation also removed from here. Oh, of course I forgot the data. Data equals my data. And here we see that all these variables are highly significant, and we have the R-square of 24%, adjusted R-square of 22.88%.